In this video, we're going to talk about the basicity and preparation of amines. This is the first video in this series, and we're going to talk about the naming of amines, go through some common examples, talk about primary, secondary, tertiary amines, talk about hydrogen bonding and solubility. We are, first of all, going to talk about our most common amine, and we're just going to go through 3 examples of simple amines before we go on to slightly more complex ones in the next slide. So the first one is phenylamine, and I do this one straight away because it shows you that amines end in this amine word, but also it can be written in 2 ways. So instead of using the amine here as you have, and you have it as a suffix, you can use the amine as a prefix. Now the prefix is amino, and if it's amino, that means the benzene component here, which is your phenyl, turns into your stem chain, and you call it benzene. Okay, well that probably doesn't make much sense now, but let's draw it and it will make a lot more sense. So when it comes to phenylamine, phenylamine is going to be C6H5, that's your phenyl. Okay, and then your amine is this NH2. So this is the simplest amine you'll come across. We'll go over a few more complicated ones as we go along, but that's the simplest one you're going to come across in terms of amine. So this NH2 is our amine, which is also our amino. So if we draw this here. Here's our phenyl. Remember that's C6H5, so one of the hydrogens is removed. And then instead of that hydrogen being there is an NH2 group. So that means our amine is that part there. Okay, so that is our amine. So we can call it in 2 ways. We can use the amine as a suffix or the amino as the prefix. Now, our next example is going to be methanamine. Now this is the more systematic name for amines. This is very, very specific to when you've got benzene or phenyl around, which is why we've shown it. But this is to do with just normal carbon chains. So you take the carbon chain of the amine, you take the length. Now we know this length is 1 carbon in length. And then we take this amine, we know it's an amine. So all we're going to do, and we'll do this in a displayed formula just to show what it looks like. So there we go. There's your carbon. Remember, carbon has 4 bonds. Also remember that nitrogen has 3 bonds, generally. Remember, it can have more, but that's in case of ions. And you can see there is our amine, methanamine. So go for the next one, which is propanamine. We do this in skeletal formula. You try and do it first if you can. Okay, it's prop, so it's 3 carbons in length. There's your 3 carbons, and there's your NH2. Now I just want to finish this off by showing you the lone pair of electrons on each one of those nitrogens. Now that means that the amine can act as a base and accept a proton. So we've got 3 simple amines. We'll now go on to looking at amines in different positions. So we've done the simple naming of amines. Let's have a look at naming some more complex ones. So we've got butan 2 amine. Now this is just introducing, as I said in the last one, a different position. Okay, and that different position, if we've got butan, that is 4. So there's your 4 carbons, okay, from here. And then you've got 2 amines. So basically I just need to look at my amine. There's 1, 2, and then go from there and put my amine on there. Remember, that can also be called 2-amino butane. Okay, so using the amino as a prefix. We then go on to a different one. So let's look at it not in terms of position. Now let's look at it in terms of the number of groups that are on our nitrogen. So the amine is telling you that these groups are all attached to that nitrogen. Let's see what that would look like. So we've got diethan. So again, I look at this and I go, where's my nitrogen? Best way to do it is stick your nitrogen in the middle and then just stick 2 ethan groups on, which is 2 carbons. That's 2 carbons. Let's stick another 2 carbons, because it said on here we're looking at diethan. So we've got di. And then, this is when I said about the start, you don't necessarily have 2 hydrogens on the entire time. So if you look here and you say, right, I've got 2 of those groups on there, how many bonds goes to a nitrogen? Well, there's 3. That means there's 1 bond left, and that 1 bond remaining must be my remaining hydrogen. Again, really important as well, just to add this, that lone pair of electrons all sitting there ready to react, but we'll talk about that later. We then go to trimethanamine. So again, we draw our nitrogen. Okay, there is our nitrogen. And then this time we've got 3 groups, the tri, and they're all 1 carbon long. So let's draw them as 1 carbon long. And then we see whether we add any hydrogens on there. We'll think about it's 3 bonds again. There's already 3 bonds filled. So therefore I don't draw any hydrogens at all. And again, just for clarity, let's draw that lone pair of electrons on the top that's left. Now, that is how you draw the slightly more complex versions of these amines. So we've gone through a few examples of naming. So we can use the suffix of amine, and that will tell us we've got an amine. You can do it with pentylamine, as we've done in phenylamine if you'd like, but the main name is pentanamine, or you do pentana and then put the amine on the end, or butana and then put the name on the end. And again, if we just quickly draw this, you can see that pentanamine, that means is 1, 2, 3, 4, 5. Okay, and then my amine goes on the end. So that's when we're using it as our suffix. Now, it is a choice what you do. You can also use it as a prefix, as I've said. Okay, and then if we use it as a prefix, 1-amino pentane, exactly the same thing, because when we look at it here, it's on position number 1. If we look at the naming from that direction. Okay. And both those names are absolutely correct. 1-amino pentane is this, pentanamine is this, pentylamine is this. Okay, so you do any of those answers and in your exam, you're going to get the right answer when it comes to naming amines. Now that we can name amines, we're going to go on to talk about how we can categorize them. So they can be described as primary, secondary, or tertiary. So what you've got to look at with primary amines, have you got 2 hydrogens on, that's a primary amine. If you've got 1 hydrogen on, that's a secondary amine. 0 hydrogens on, that's a tertiary amines. There's also another rule, and that rule is if there are different length groups on the nitrogen that forms the amine, then the shortest structure has the N prefix. And depending on how many of those groups are on there, so for example, you've got diethyl here, so there are 2 groups on that nitrogen. I have to include an N for each one of those groups. But we will go through that in order. In this one I've used pentylamine, but you could use pentanamine as well. So let's put this to the side and let's go through some examples. So you've got propanamine. So with propanamine, I've got 3 carbons and an NH2. Now if you think about that, whether it's primary, secondary or tertiary, and we look over here, we can see that primary says it's 2 hydrogens, so therefore this is a primary amine. Then go to the next example, butan-2-amine. So again, this butan means we have a chain of 4 in length, 1, 2, 3, 4. Okay, and we also have a NH2 coming off position number 2, because it says 2-amine. And if that is the case, we then again look at the nitrogen on here, and we describe that as a primary amine again, because it has 2 hydrogens on it. Then look at diethanamine. So diethanamine, if you look here, we've got that nitrogen, it has diethan, so it's got 2 groups on it, and then 1 hydrogen. 1 hydrogen would mean that that's a secondary amine. And let's go on to look at 3 more examples. So trimethanamine, again you count the groups. You've got 3 groups on there, and therefore no hydrogens on the nitrogen. Therefore, if there's 0 hydrogens, that is a tertiary amine. Then go to N-methylethanamine. So N-methyl etham. So if we go to that rule that we did earlier, and if we just go across here, if there are different length groups, then the shortest structure has an N prefix. So methyl is shorter than eth. Because it's shorter, it has the N prefix. And there's only one methyl, so there's only one N. So if that is the case, N-methyl means that that methyl group will go on the nitrogen, and so will an ethyl group. So I've got my ethyl group here, I've got my methyl there, and then I categorise it again, one hydrogen, secondary amine. We then go for a slightly more complicated version, NN, diethyl propanamine. So our stem chain again is prop, so it's 3 carbons coming off the nitrogen, and then I have 2 shorter chains. So shorter chains are 2 carbons each. There's 2 of them, so I need 2 ends, and it ends up with this prop group, and then these 2 eth groups here. And that is how you write the names relative to the structures, and you differentiate between a primary, secondary, and tertiary amine. And what properties do amines have? So let's look at this diagram here. You will hopefully have heard from your teacher or from other videos and things like that, that rotting animal flesh is what they smell of. They're disgusting to smell. So when you have the wafting technique, when you're in the class, wafting it towards your nose is a good idea when it comes to amines because they stink. Okay, so it's really important that you don't spill it on yourself, otherwise you'll stink of fish. Okay, now specifically the dimethanamine and the trimethanamine are found in those areas. And like I said, some of the other ones really are disgusting because they smell of rotting animal flesh, and nobody wants to smell like that. Okay, so be very careful when you're around them. So hopefully you're aware by now that high solubility in water due to hydrogen bonding. And if you weren't already, think about that lone pair that I've kind of been drawing all the way through, and think about the fact that you're going to have some delta positive and delta negative areas. Well, let's remind you of that. If you're going to go ahead and you do this before me, and I would encourage through the videos that you do things before me sometimes. Don't just watch the video, stop it, try and do what I'm going to do. I'm going to use propanamine. So try and draw a hydrogen bond with propanamine before I do it. Okay, so let's get this across. So I said it was going to be propanamine, so let's draw propanamine. So that's 3 carbons. I've got my 3 carbons, and then I've got my NH2 group. So I'm going to draw it with the hydrogens coming off. So there you go, there's your hydrogens coming off. I'm then going to put my dipoles on, really important. So my dipoles are going to be delta negative because nitrogen is more electronegative than hydrogen. So it's going to pull those electrons towards itself because it's more electronegative, and I'm going to draw my lone pair of electrons there as well. So there it is. Remember, a hydrogen bond can happen if you have a delta positive hydrogen, and that happens because it's attached to N, O or F, nitrogen, oxygen or fluorine. So then I'm going to do my water. So here's my water. I'm going to show the hydrogen bond between. So I'm going to do my dipoles again. So there's my dipoles. And then I'm going to draw the hydrogen bond between the delta negative and the hydrogen. But first of all, I need to put in my lone pairs. So think about it, marks in the exam. Lone pair will be a mark in the exam. Delta negatives, delta positive mark in the exam. Final mark in the exam is going to be your hydrogen bond between a negative and a positive. So between a negative electronegative element and a positive hydrogen. Now this shows that these amines have a higher solubility in water compared to the other things with a similar molecular mass. So basically this will be more soluble, for example, than an alkane would be because it can hydrogen bond. Now once the molecular mass changes though, what happens is if you get a longer chain coming off your amine, then that hydrogen bonds will be disrupted, and therefore you will not get that increased solubility. So just as with alcohols, if this chain gets longer, you will get less solubility. So it's really important that you recognise the fact that these small chain levels you're going to get these hydrogen bonds, and you may well have to draw it, which is why we've drawn this for you right now, and why it's good before you sit your exams to practice doing hydrogen bonds with both alcohols and amines.